This is a recording for pre-calculus, and it is on section 1.9, which is called inverse functions. And so first, I just want to kind of preview this a little bit and just remind you of some things that you already know. So I'm going to put a couple of axes here. And just kind of, I don't know if I need that many, but if you remember, if we have a parabola, or if we have x to the third, maybe we'll call that, or we have a circle, and or we have, well, I'll put a parabola kind of this way, but then I'll kind of do this as well. So if you kind of look at these 1, 2, 3, 4, 5 things. Just a couple things. So this first one is maybe y equals x squared. It is a function, and if you remember, for functions, we have a vertical line test. So I'll just kind of put a little vertical line there, and I'll drag it across. And this passes the vertical line test. It only hits at most one place. This one, which is maybe x to the third, also passes the vertical line test. A circle is not a function because it doesn't pass the vertical line test. And this kind of tipped parabola I have there does not pass the vertical line test. But if I only use half of that tipped parabola, then it would pass the vertical line test. So we're kind of used to the vertical line test and kind of testing for a function. And so this first parabola is a function. This one's a function. No for that. This one would be no, but if we restrict it, restricted, and it just gives us this half of that, maybe it's the square root of x, then that's going to work for us as we look at these. So that's the vertical line test. In this section, we're also going to have the horizontal line test. And so let's go back here. This parabola is a function, but look, there's places where a horizontal line crosses twice. But here on x to the third, or maybe x to some odd power, it only crosses once at most. Circle, still nothing. This one, if I would do this whole thing, it would be, but originally it was not. But this restricted domain also will pass now the horizontal line test that we're going to encounter in this section. So just some little reminders about functions as we get started. Our objectives are to find inverse functions informally and verify that two functions are inverses of each other. We'll use graphs of functions to determine whether functions have an inverse, and that's going to be where we're using these tests. And we'll use this horizontal line test to determine whether a function is one-to-one or functions are one-to-one. And then we'll find the inverse functions algebraically. So a relation could be a function or not a function, and if it is a function, it could have an inverse function, or it could just have an inverse relation. So, you know, there's a little fine line there that you want to be kind of aware of as we go. So our first subheading is inverse functions. And so we know about functions already. So if we have f of x equals, if we have f of x equals x plus 4, and we want some ordered pairs, if x is 1, y is 5, if x is 2, y is 6, we can make a bunch of ordered pairs. And if we wanted the inverse of that, we would just interchange the first and second coordinates, and then that would be the inverse function. And it's denoted as f to the -1. It is not 1 over f of x, but it is named f inverse is kind of how we'll refer to that as we go. So just kind of thinking about the same situation a moment, if x is in the domain of f and then we kind of find its range value, f of x. Then if we look at the inverse, this is now going to be the domain, and it's going to go over here to the range. And so they just kind of work back and forth. And the functions f and f inverse have a effect of undoing each other. You know, if you think back to elementary school, you maybe learn to add first, and then we kind of undo adding by learning to subtract. You learn to multiply, you undo multiplying by dividing. You square, you undo squaring by finding the square root. So you've been doing and using inverses for a lot of your education in mathematics, but now we're kind of formalizing that a little bit. So the next thing is kind of to look at this as a composition of functions. So kind of look at this, it's going with this nested. So f of f inverse of x, when we put that in, notice, look, we get back out just x. And if we take f inverse of f of x, we also get out x. So what that kind of means is that if we take f inverse composed with f of x, we get x. And if we take f composed with f inverse of x, then we also get x. So what that also is going to mean is that inverses are reflected over the line y equals x on a coordinate plane. So that's something that can help us if we don't have a algebraic rule. If we just have a picture, we can reflect that over the line y equals x and find the inverse that way. So here's our first problem. It says find the inverse of f of x equals 4x and verify that both f of f inverse of x and f inverse of f of x are equal to the identity function. And the identity function is just y equals x or f of x equals x. So in this one, they're asking us to find it, and you might be thinking, you know, well, we really haven't said much. But if it's a simple one operation, and we know what the opposite operation is, it should be pretty straightforward to us. So for number one, if f of x equals 4x, and so we're taking 4 times x, then f inverse of x should equal doing the opposite of that, so x divided by 4. And so now we want to, that is to find the inverse, so done. Now we want to verify that this is equal to x, so I'm just going to write f of f inverse of x. And we'll do this just like we did with the composition of functions. So I want f of, and the first thing I'm going to do is I'm going to put f inverse in for that. So I'm going to put in that x over 4, but I'm just going to write it in green here. X over 4. And then when I put that in, I'm going to do f of x over 4. So I'm going to put in place of this x, the x divided by 4. And when I do that, I'll get 4 times x over 4. And that's like 4 over 1 times x over 4. So that is equal to x. So I'm going to put a little check mark and I'm going to say, woohoo, good. I'm excited about that. But I have to check the other one as well. So now we're going to see what f inverse of f of x is. And again, I'm going to put f of x now, the 4x, in there. So I'm going to write that as f inverse of 4x. And since I'm using f inverse of 4x, I'm going to put 4x where that x is there. And so I'm going to put 4x over 4. Well, that simplifies to just be x as well. So both of those are equal to the identity function, which is just x as we go. So that is our first inverse that we've done. It's not always going to be just that apparent of how to find that. Next, we want to write a definition of an inverse function, just so that we have a good knowledge base for this as we go. And you're going to want to write some things. I'll kind of trace things as I read it. So it says, let f and g be two functions such that f of g of x equals x for every x in the domain of g, because remember we start with that nested inside one, and g of f of x equals x for every x in the domain of f, because you're putting it in f first. If these are the conditions, then g is the inverse function of the function f, function g, oops, the function g is the inverse of the function f, and we can call g then, we're going to rename g as f inverse. So then we really get this is the critical thing, and the domain of f has to equal the range of f inverse, and the range of f must equal the domain of f inverse. So if you need to write a little more there, go ahead. You do want to know this domain and range thing and the thing that I circled there for sure. And I'm going to move on to the next slide. So just be careful, you know, in an algebra expression, if we say x to the -1, we know that that is 1 over x. Sorry, I'm not writing very well right this second. That equals 1 over x. That's not true. F inverse of x does not mean, is not 1 over f of x. No, don't do that. So just know that that is not going to be the case as we go through this. And it's just a new notation to say that it is an inverse as we go. Problem number 2 is to try and verify inverse functions. So it says determine or show if either h of x or g of x are inverses of f of x. So if we were together all the time and we were doing this in class, I would just say to you, well, there's f of x. X minus 4 divided by 7, which one do you think maybe is the inverse of that? Just to kind of think about that. So pick one, or maybe you think neither of them are, or maybe neither of them are. So it's either G or H or neither of those. So we're going to check it and see, and we're going to use this process, and we're going to say if I can find f of f inverse of x to equal x, question mark, and then if that works, then I'm going to try f inverse of f of x and see if that's equal to x, then they'll be inverses of each other. And really, it doesn't matter which one I try, but so that is just fine. So let's just try h of x and g of x. I think I labeled these backwards from what I was maybe going to label them. Let me, yeah, I did, but that's okay. So we'll check g of x here. I think I feel like I want to call that one h because I think that's what the book authors have called it. So I'm gonna just change my notation there. So first we'll check h of x and see if that is an inverse. So I'm going to take f of h of x to kind of check. So it's really h of x that I'm seeing if it's the inverse. So that means I'm going to go f of h of x is this 7 over x minus 4 So you can see why it's important that you do like the previous lesson before you do this lesson, because they definitely build on each other. And then I'm going to put that in f of x. So in place of this x right here, I'm going to put that whole thing. So if you haven't practiced those yet, you want to kind of keep that in mind. So it's 7 over x minus 4 over 7. And I've got to do kind of some manipulating here. So I'm just gonna leave this 7 in the denominator, but 4 I'm gonna say is 4 over 1. I'm gonna get a common denominator up there by going x minus 4 over x minus 4. And then that's going to give me 7 minus 4x plus 16 all over x minus 4, and it's still all over 7. And when I do that, I'm going to get 7 and 16 is 23 minus 4x over x minus 4, still all over 7. And then I'm going to invert and multiply. So I'm just going to scratch that out and multiply by 1/7. And I'm not even going to have to really figure that out. 23 minus 4x over 4x minus 4 times 7. I'm going to say this is not equal to x. So this is not an inverse. So h of x is not the inverse of f of x. Because, you know, if it isn't going to equal x, I can just quit and say, no, it's not going to work, and then just move on. So now we'll try this one that is g of x. So f of g of x. And so again, I want f of the inner function is g of x, 7x plus 4. And then I'm going to go back to this f1 again. And in place of this x, I'm going to put 7x plus 4 right there. And then kind of just simplify and see what happens. So that means I'm going to have 7x plus 4. I'll put it maybe in parentheses minus 4 over 7. And then that's 7x plus 4 minus 4 is 7x over 7, which equals x. So I'm going to just put a little check mark, and I'm happy about that. But I just will comment that we do have to go the other direction as well. So we have to now see what g of f of x is. So I have to make sure it works both ways. So now g is the outer function and f of x is the inner function. So I'm going to put this right there now. And that's going to be x minus 4 divided by 7. And now I want g of that. So g of x, in place of that x, I'm going to put this whole thing right there in place of that x. So let me kind of back up a little bit. And that means I'm going to take 7 times x minus 4 over 7. And then I'm going to add 4. And let's kind of see what happens there. So the 7's cancel. I get x minus 4 plus 4, and that is x. And those are the same. So I'm going to say f and g are inverses of each other. So H didn't work, but F did, and so did G. So we're kind of good to go there. And it could happen that neither of them would be inverses, and we just kind of have to experience that and then move on. If you need to look at this, pause. Otherwise, I'm going to go to graphing. So this is next subheading, and that is the graph of an inverse function. And I am going to tell you that you know, this is a little weakness for me. It's hard for me to sometimes graph these, but we're going to plot points, and that will help. But I just mean my drawings are not always super great for this, but I will do my best. And hopefully you will also. And we will use grid paper. That is important because it'll help you kind of find where things are exactly closer. So look at this graph. And the graphs of inverses are related in this way. The graph of F inverse is a reflection of the graph of F in the line y equals x. So that little pink dashed line that goes through this way, that's where like the points are 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. And so I will, at least right now, trace, and then I'm going to get rid of it. So if this is f of x, then the inverse, which would be f inverse of x, would go like this. And I want you to notice a couple of things, and they kind of show this. If you draw a little perpendicular line from this point to this point, those are well, perpendicular, I was going to say, and this distance and that distance are the same. Also, if the function crosses that line y equals x, then the inverse crosses at that point also. So if this is close, then this is the same distance. If whatever that distance is the same. It looks kind of like a little fish there. There we go. Oh, how awesome. I'm going to get rid of all that. And so that is kind of the graphing of an inverse. And just to keep my life, pretty easy, we're going to start with just a line. And so I should be able to graph the inverse of a line, and so will you. So this gives us our functions, number 3. And I think we're going to do 2 graphs. So get some graph paper out if you don't have some handy right now. And then we'll look at this. So it says sketch the graphs of the inverse functions f of x equals 2x minus 3 and f inverse of x equals 1/2 times parentheses x plus 3 on the same rectangular coordinate system, and show that the graphs are reflections of each other over the line y equals x. So we're actually just going to graph 3 things, and I'll kind of color code them right now. We'll go f of x will be 2x minus 3, and I'll do that in green. We'll say, yeah, we will. And then I forgot that I usually do my y equals x in green, but that's okay. I'll find another color. And then f inverse, I'll do in red, of x is 1/2 parentheses x plus 3. And I'm just going to remind myself while I'm writing in red that that's 1/2 x plus 3/2. So if I want to kind of use that slope intercept form, I can. And then the last thing we'll graph is the line y equals x. And I'll do that as a dashed line in blue, if I remember. Okay, so now we'll just, graph these 3 things and kind of look at that relationship. So the y-intercept here is, oh, and that's my page number, that little 14. Sorry that is there. It's annoying me right this second. So I think that I'll just get rid of that. Oh, just kidding. I almost got rid of it, but I did not. There we go. And then I've got to do a little order thing and bring this to the front. Okay, perfect. I just am happier with that graph looking like that. And now I'll plot some points, and you can make a little table of values. Your calculator does that if it's more complicated than this. But my y-intercept is -3. My slope is 2, so up to over 1, 2, 2, and now I'll graph that, and I'll use some kind of green color. And it doesn't really look like I'm doing hitting the mark job, so I'll do a little, maybe making my line a little better here. There we go. So this is, oops, just, let me, there. That is kind of the line. There we go. That is y equals 2x minus 3. And then my next one is going to be, well, that goes through 3 halves, which is 1.5. And then it goes up 1 and over 2. Um, Up 1 and over 2. As we look at that, up 1 and over 2, I think I can graph that like this. So now let's kind of get that line in there and oops, just kind of make sure I'm as close as I can get to that. And so here's the line, y equals 1/2 parentheses x plus 3. And now I'm going to put in there this line, and let me just kind of manage some things here. Yeah, I think that's all going to be good, and I'm going to do this. And so this is just the line y equals x. So it goes through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and oh, I put away my line, sorry. And I want that to look like this, and I know it goes right through there, and I kind of can't quite get to there. There we go. And if I did an awesome job, you would be able to see that this kind of intersects all at the same spot. So I'm going to just kind of move it. If x is 3, y is 3 on this red one. So I was a little kind of off the mark there, but I think I can kind of fix it that way. And it might be that, there we go, it'll look better if I'm a little more like this. And that is going to be as good as my graph is going to be. So one thing I will tell you is when you're graphing this, if you have to graph the reflection over that line y equals x, you can graph the original function, and then after you graph the original function, you can graph this line y equals x, kind of fold it in half. I think I maybe mentioned to some of you that I didn't have a graphing calculator. There weren't graphing calculators. And so when I did things, we would just darkly draw our original function, fold it over y equals x, and kind of press on it so that we got that little shadow image, and then draw it from there. And then I just have a slide, here's some coordinating points so I can see that what was x and y before they switch places for the inverse. And so what was x becomes y, what was y becomes x. And so that's a critical learning that we want to do. We want to know that x becomes y becomes x, and that will help us down the road. Now we'll graph one that's maybe just a little more challenging or interesting as we go. So, and I'll try to stay with these same colors I just used. So f of x is going to be x squared plus 1. But notice it has a restricted domain. It's not the whole parabola. It's just from 0 on. So let's think about putting 0 in there. If I put in 0, I get 0 plus 1, which is 1. If I put in 1, I get 1 squared, which is 1, plus 1 is 2. If I put in, maybe I'll just make a little table x, y, 0, 1, 2, 3. I think maybe I can get 3 on there. So this was 1. We already did that one was 2. 2 squared is 4, plus 1 is 5. 3 squared is 9, plus 1 is 10. So I'll just plot those 2, 5, and 3, 10. And then that half of a parabola kind of looks like that. And so that's our original. Now we'll graph the inverse. So f inverse of x, just a second, I'm going to write that just a little better. F inverse of x is equal to the square root of x minus 1. Now notice it didn't technically restrict the domain, but we know when we do this, the domain has to have this part, has to have x minus 1 under the radical greater than or equal to 0. So here x has to be greater than or equal to 1. And so I'll make another table of values of x and y. So I might as well just start 1, 2, just I'll do 1 and 2, and then I think I'm going to do 5. And that should be 10, and maybe I'll do 10, and that should be 3. But let's just validate that. So 1 minus 1 is 0, square root of 0 is 0. 2 minus 1 is 1, square root of that is 1. 5 minus 1 is 4, square root of 4 is 2. 10 minus 1 is 9, square root of 9 is 3. So notice that XY table, we kind of are interchanging the X's and the Y's. Now I'll plot these. I'm at 1, 0, I'm at 2, 1, I'm at 3, 4, 5, 2, and I'm at 10, 3, and it's going to look like that as we go. And so there's the two functions that we have. And now we're going to also graph that line y equals x, just to show that is a reflection as we look at that. And I'm going to do that as this little dashed line again. And I'll do it in blue. And if I just kind of drag from that corner to that corner, because my graphs are always generally 10 by 10. And you can see that if you would have that on a piece of paper and fold it in half, those are reflections of each other. And so you want to practice graphing those because that is going to be important. Now we're going to talk about one-to-one functions. So one-to-one functions means that we know for a function for every x, there's exactly one y, but now for every y, there's going to be exactly one x. These are rules you've maybe encountered before, and so I'll go over them. This is the horizontal line test for inverse functions, and I'm just going to kind of circle it. You can write something down about it. A function f has an inverse function if and only if no horizontal line intersects the graph of the original f in more than one point. So take a minute, write that down. Pause this if you need to, because I'm going to go on to the next slide. And if f is a function and it has an inverse function, these are called one-to-one functions. So you want to write this down also. Function f is one-to-one when each value of the dependent variable corresponds to exactly one value of the independent variable. A function f has an inverse function if and only if f is one-to-one. So, it can still have an inverse relation if it's not one-to-one, but it has to be one-to-one in order to have an inverse function, just to kind of let you know. Pause this if you need to write more there, and then I'm just going to move on. So look at this, f of x equals x squared. We already know that's a parabola. And it is a function. If you think of the vertical line test, if I put a vertical line there, freehand drawn, it's only going to hit one time every vertical line. But if I draw a horizontal line, and it's okay if it doesn't hit it at all in places, because as I come up here, it's not hitting it at all. Look, it hits just once there, but then it hits 2 times. And so the thing is, for the inverse, which is not going to be a function but a relation, if x is, let me write some numbers on here. Maybe this is 2 and this is -2, and we know this would be 4 then. So if x is 2, y is 4. If x is -2, y is also 4. So if x So if we flip that to be the inverse, if the y is 4, do you know without a doubt, if y equals 4, do you know without a doubt what x is? And the answer is no. It could be 2 or negative 2. So this is not 1 to 1. So not 1 to 1 function. So it may have an inverse relation, but it won't be an inverse function. Moving on, um, that one just kind of talks more about that one we just looked at. This is number 5. It's kind of pre-done for us, but we'll just look at it. So here's the graph of x to the third minus 1, and there's just asking us to apply the horizontal line test. So if I draw a horizontal line here, and I'll just snap one in there, and no horizontal line intersects at more than one place. So here f of x is a one-to-one function, and it does have an inverse function. So that's what we're looking at for 5a. 5b, same thing, it's kind of pre-done for us. So 5b shows this one, f of x equals x squared minus 1. When we try or use that vertical line or horizontal line test, and we kind of drag that around, it's hitting it more than one place. So this one is not 1 to 1, and it does not have an inverse function as we go. So that's kind of the graphing parts of all of this. Now we want to look at finding inverse functions algebraically, and we have a little set of rules for how to do that. And then we'll do kind of 4 problems, I think is what I have on the slides, just to kind of get a really good idea of how to find these inverse functions algebraically. So, you know, this says when it was a simple one, it was easy, but now when we have a lot going on, we have to be careful. So I'm just going to highlight and go over this. So the first things for the 5 steps for finding an inverse function. 1, just using the horizontal line test, decide if it has an inverse function. And so that's not necessarily anything you write down. Then in the equation, wherever f of x is, you replace f of x with y. That's a very easy, and kind of 2 and 3, a lot of times we kind of, well, 2, 3, and 4 kind of all are step by step. These are the kind of algebraic steps. Then once you write it as y, with y, then you interchange x and y and solve for y. And then at the end, once that new y is alone, you replace that with f inverse. And then after that, step 5 is to verify that they're inverses, and showing that the domain of f is equal to the range of f inverse, and the range of f is equal to the domain of f inverse, and kind of that these things work as well. So just f of f inverse of x equals x, and the opposite is true also, f inverse of f of x equals x. So let's dive in and kind of look at some functions that we're going to find the inverses of. I'm going to be super blunt and say you want to be able to do this because there might be a problem like this on, like any of these 4 on your next or your first exam here. So 6a. Here's f of x, so we'll go through those. I'm not looking at the steps, but I kind of know. And I'm just going to tell you this one is going to have an inverse function. And so I'm going to say f of x equals 5 minus 3x all over 2. So at some point, I just change f of x into y. So y equals 5 minus 3x over 2. I'm going to color code this, and a lot of times I do a little dash line. It's not necessary, but I'm going to now change this y into x. I'll leave all those equals 5 minus 3. I'm going to make that the y divided by 2. and then I'll just go back to black. So I interchange x and y. Now I have to get that y alone. So I'm just going to rewrite it. X equals 5 minus 3y over 2, because this is your notes, so I just want to be really clear. I'm going to multiply each side by 2 to get, rid of that fraction. And when I do that, I'm going to get 2x equals 5 minus 3y, because those canceled. I'm going to add 3y to both sides. And then I'm going to, oh gosh, no, I'm not. I was thinking, I'm not going to add 3y to both sides. I want to get y alone. Oh, I could have. Well, whatever. I'm gonna subtract 5, so I get 2x minus 5 equals negative 3y. I'm gonna multiply. I will reflect it. So negative 3y equals 2x minus 5. Then I'm gonna divide everything by negative 3, and then I'm gonna get y equals negative 2/3 x plus 5/3. And I wrote it that way. I might also just keep it as a fraction, but maybe put the 5 minus 2x over 3 and say there it is for the inverse. So I'm not going to go through the process right now of checking all of that, but that is our inverse function, just so that I can kind of get through all of these, and then maybe we'll talk about domain a little bit on one of them. Then 6b, if you want to pause this and try to do this yourself, f of x is 5 minus 3x over x plus 2. You definitely want to know how to do one like this. And so then we change it into y equals 5 minus 3x over x plus 2. And this does have an inverse function. I didn't quite go over that, and I'm not going to take time to do that. Now we interchange the x and y. So we're going to say x equals 5 minus 3y all over x plus 2. Now, this one, I'm going to just be super honest and say there's a little more work to this, and you kind of have to think about how you're going to get y alone. So the first thing I'm going to do is get rid of this fraction. So I'm going to multiply by x plus 2 on each side. And then here, it's going to cancel on that side. And then I'm going to have over on here, oh my goodness, I made a big mistake here. When I wrote that, I did not change that x into y. That's why we're going to have an issue here. So I am just going to change it into red here. So hopefully you can follow. I forgot to change that. And because in my mind, I was thinking I should get xy there. So I'm going to pause this a moment, and then I will be right back. So moving along, now that I corrected my little error there, I'm going to distribute on the left-hand side. So this is going to be xy plus 2x equals, and then it's just going to be 5 minus 3y. So remember, my goal is to get that y alone. And so I have y on the left and y on the right, and I have that xy. But what I need to do then is get my y's on one side and anything else on the other side. So I'm going to add 3y, and I'm going to subtract 2x. So I'm going to get xy plus 3y equals 5 minus 2x. And now I've got the x's on the same side. Now I'm going to notice I have a common factor of y, so I'm going to distribute that out, and it's going to be y times x plus 3 when I distribute that out equals 5 minus 2x. And then I'm going to divide each side by x plus 3. And on the left, the x plus 3's cancel, and I get y equals 5 minus 2x over x plus 3. Now, look at that compared to the original. And I'm just going to write both of them where I can kind of see both of them at the same time. I'm going to go back up here and I'm going to just rewrite f of x is 5 minus 3x all over x plus 2. And, oh, I didn't make that f of inverse then. So then when I have y equals that fraction, I'm going to change that to f inverse of x equals 5 minus 2x over x plus 3. And I'm going to write that up here now. So f inverse of x equals 5 minus 2x over x plus 3. And so maybe just kind of study that problem. You want to be able to do something like that as you move on. And I have a couple more problems to do for finding inverses. So in this one, f of x is the square root of 2x minus 3. So I'm going to go through my process, and I'm not validating that this is one-to-one. I'm telling you that this one's one-to-one. You would want to be able to validate that for yourself. And I'm also not checking them at the end, just to kind of try to get through the rest of this lesson. And so then I change f of x into y. So y equals the square root of 2x minus 3. And then I'm going to just draw my little dashed line because now I'm going to change it. And I'm going to say x equals the square root of 2y minus 3. So in this one now, I want to, I'll just rewrite that square root of 2y minus 3. Now I want to get y alone, so I'm going to square both sides first. And when I do that, I'm going to get, oops, let me push my page down just a sec. I'm going to get x squared equals square rooting and squaring cancel each other out. 2y minus 3. I want to get this y alone. I'm going to add 3. X squared plus 3 equals 2y. I'm going to divide by 2. So x squared plus 3 divided by 2 equals y. And then I'm just going to flip those, and I'm just going to go f inverse of x equals x squared plus 3 divided by 2. And again, I kind of am liking thinking about writing these next to each other. So our original here is f of x equals the square root of 2x minus 3, and then our f inverse of x equals x squared plus 3 all, there we go, divided by 2. And can you see how that's doing and undoing kind of as we go? I'm going to move on to the last one here. And this is f of x equals the cube root of 10 minus x, or plus x, excuse me, 10 plus x. And so I'm going to go through that same process. Y equals the cube root of 10 plus x. Draw my dashed line. Now I'm going to replace the y with x equals the cube root of 10 plus, and this will be y. I'm going to go through that same process. X equals the cube root of 10 plus y. I'm going to cube each side this time. And then that's going to give me x cubed equals, cubing and cube root cancel each other out, 10 plus y. I'm going to subtract 10, and x to the third minus 10 equals y. And then we're just going to change that into y equals x to the third minus 10. Change that into f inverse of x equals x to the third minus 10. So I'm going to slide this up. F of x was the cube root of 10 plus x, and f inverse of x is x to the third minus 10. And that is the last problem here that we're going to look at today. And so you want to be able to find inverse functions informally, verify that two functions are inverses of each other Use graphs to determine whether functions have inverse functions. Use the horizontal line test to see if functions are one-to-one, and find inverse functions algebraically. So that concludes the notes for section 1.1, and we're going to have our first exam on sections 1.1 through 1.9. Have a great rest of your day.